Welcome to It's a Controls Problem, where we do precision guesswork based upon unreliable data given to us by those of questionable knowledge. I'm your host, Charles Johnson. All right, and welcome everyone to another episode of It's a Controls Problem. I'm your host, Charles Johnson, and I'm here with no other but the great Matthew Vanberg. Matthew, how are you?
Hello, sir. I'm good. How are you doing today besides the weather?
Oh, I am just peachy keen. And we have a very special guest. He is a repeat, or I will call him a repeat offender of the podcast. He is now a two-timer on here. Mr. Keith Gipson. Mr. Keith, how are you today?
Doing good. Great to be here.
So just to catch everyone up, for those of you who are not familiar with Mr. Keith Gipson, if you did not see or listen, I wouldn't say see, but hear the last episode that we had with him, it was sometime last year. He is the founder of Facile.ai. So Keith, if you want to give a brief overview of what Facile.ai does, that'd be fantastic.
Sure. So Facile AI provides AI and machine learning solutions for the built environment using autonomous AI to control and bring a greater degree of precision to HVAC mechanical equipment, central plants, rooftop units, air handling units, et cetera, et cetera.
All right. Yeah, that is the 1,000-foot view. It also does so much more than that as well. But yeah, that is the quick catch up for that. And the last time that you were on the show, you were heavily pushing the mission of making autonomous buildings a real mainstream reality. So catch us up. So what's that ride been like since we last spoke? And is there a really large professional or personal milestone that you've crossed during this time?
Yeah, I think we're crossing the chasm as it was. And we AI has been on the scene for at least 3 years now with ChatGPT and all that stuff. I think it's starting to become mainstream. We had a lot of pushback initially against AI running buildings autonomously. So we figured out that we quickly had to build trust, and it takes time to build trust. So I always say, this is a reputation-based business. So, it's not going to be overnight, but we just have to keep engaging one customer at a time, creating value and trust in our system. And I think we're getting there as far as people trusting, just like a full self-driving, robo-taxi with Tesla, that trust had to be earned. I think we're doing the same thing with our product, which I term full self-driving for buildings.
Yeah, I was in Vegas during AHR.
Yep.
It was they weren't the Tesla. I forget what they were called, Exo something. I forget what it was. Yes. And so, it was super weird to watch. I decided to get one just because it's all right, let's find out. And it was super weird to just have no one in there with you, and then just kind of driving around, then just see them driving up in their own specified lane. And it picked me up. I was like, so come here often. So I was just kind of having fun with myself in the, that sounded wrong. In the vehicle, but it was a rather interesting experience that I had. So yeah, you are seeing that more and more these days. Everyone loves a win, and especially in an industry that can be slow to adopt the new tech, as you know, it is. People are slowly adopting it, but it hasn't caught on like wildfire just yet. But can you share a recent project success story where your approach turned around a building's performance, and what did those numbers look like?
Sure. That's very relevant, especially with the issue of trust and resiliency. So 4 months ago, I made the rather, controversial decision to take what I call the guardrails off of our AI. So everybody's talking safety guardrails, limits, human imposed limits on the AI. And the last time I checked, like if I got into a Waymo or a robotaxi and I saw a person there sitting at the steering wheel, and I'd say, what are you there for? Oh, well, I'm here to make sure that it doesn't drive off the cliff or, crash. And I don't think I'd take that thing. So you have to trust in the technology that is ready for prime time and that is going to work. So we're going against the industry standard. Like everybody's talking safety, comfort language, I called it. We've got safety limits, guardrails. And I'm like, no, you know what? It's time to take these things off. And the result was that we actually had a significant increase in our performance of our AI, because it turns out that the safety limits, the human imposed limits, were actually attenuating the results. And I'll give you exactly what the numbers were. So before our AI, the guardrails were taken off, we also had a routine in there that was impeding how fast the AI could make adjustments. So it's like, you don't want to make too quick of adjustments on the set point. So I think we kind of, attenuated it, to do like, you can't do more than a half a degree change every 5 minutes. And what happened was the AI was achieving great results. So we were at 48% at Kenny's at Cal State Dominguez Hills, where we built this stuff. And, I was talking to Kenny and I'm like, man, we've kind of hit an impasse. I mean, 48% is huge. I mean, the typical return is like 15, 20%. So we're already doubling up or tripling, what the status quo is. And then, when we took the guardrails off of that and we let the AI run free, unfettered, man, we added another 12% to the savings and energy efficiency. It went up to 60% plus. We're knocking on the door of 70% savings at time just by taking the guardrails off. So lesson learned, it was the right decision. The AI, the machine intelligence, was being hampered or hindered by the human imposed guardrails, which we thought needed to be there. And that was a huge success. So we actually increased the savings by about 15%. And that's what our competitors are achieving on their own. And we are netting an additional 15%. So that was an incredible moment for us.
Yeah, that's wow. 60% and then even increasing. That's that's quite that is quite a jump. I remember the 48 or the 38. Yeah, I remember the 48%. And Kenny, I believe, even mentioned that in our episode. And it's been a while since actually we've talked to Kenny about it. But yeah, I think you're right. I think in some cases guardrails just kind of have to be taken off, because you don't know what it can actually do until there are no limitations. As long as you aren't allowing Claude to delete your entire database off of a system, like, shame on you for allowing that to even happen. But obviously, those are the things that you aren't doing. But I think that for what you're doing, adding another percentage that you did like that, that's still even a significant jump even more. So I assume at that point, it was probably changing set points more rapidly than
more aggressive. It wasn't more rapid, but the swings were, so this thing, it took off and it was adjusting the outside air wet bulb temperature condenser water set point anywhere from 2 degrees above outside air wet bulb, which is kind of like the floor, to 22 degrees above outside air wet bulb. And that just flies against conventional wisdom, because everybody knows that, you want the water as cold as possible and it should always be within 5 to 7 degrees of outside air wet bulb. And the AI taught us different.
Yeah, because obviously, for those of you who don't know, that's called cooling tower approach.
Yes,
effectively, where physically you cannot get the water below the wet bulb temperature, and so normally you keep a dead band, and cooling tower manufacturers.
Right? You're following the terrain, right? So
Yep, exactly. And so, yeah, like cooling tower manufacturers anywhere between 5 to 10. But yeah, 2 to 22. That is quite an enormous swing.
Yeah.
So I think that's actually really awesome to see something like that, because yeah, most people would be very scared to even do anything like that, or even think of a calculation that, well, obviously you thought about the calculation because the AI did it there, but for a human thought to do that, there's no way that a human would do that. It's like when you're playing chess against a computer, and what's a computer move versus like a human, like a logical human response. So I think that's really awesome that you did that. I mean, and great for up to potentially 70% in savings at times. That's just so huge for them.
Yeah, thank you. We're very proud of our performance. We're at the central plant level, where ASHRAE says 0.72 is standard, 0.65 is good, and the best that a central plant or a chiller can do is 0.45. We're right now we're at 0.35, 0.38, 0.35 at the central plant level, and we're dipping down below 0.2 kW per ton at the chiller.
Wow.
Like, it's just ridiculous.
Yeah, I was gonna say, I'm like, I mean, I'm sure you can't even hear the chiller at that point.
No, it's coming along. It's putting out, we got 1,000-ton chillers putting out 1,200 tons at 70% capacity.
That's amazing. That really is. So like when you look at those successful deployments that you have, like, what was the unlocked potential that you had? So I'm assuming that what does a BAS system, what can't they see on their own that AI can?
Okay, yeah, excellent question. So not only it's a data scarcity problem, and it also is a low resolution problem. So I'll give you an example. Whenever you try to compare human capability to AI, to machine capability, some cases the machine is going to blow the human away, and sometimes the human will win. But most of the time, when there's a disparity, the human being is going to be blown away by the AI. Now, I'll give you an example that actually got me started thinking about this. I have a Mercedes SUV, and it's got this auto park functionality. So, call it AI or machine learning if you want to. But yeah, basically it parks itself. It parallel parks. It's, big SUV. You pull up next to the car, and it indicates when it sees it's got cameras all around. It sees, it's like, this is I can do this. I can do this based on how far away you are from the car. And you just hit the button and take your hands off the wheel. Now, this thing scared the heck out of me the first time it did it, because I was actually I bought it from a friend of mine, and he was talking me through it, and he's like, Keith, don't touch the wheel. Don't touch the wheel. Don't be afraid. And I'm telling you guys, that thing, it didn't do like we do, like it's turning the wheel all slow and backing in. Nope. It came back at a predictable speed, and boom, it went lock to lock, like 3.5 turns locked in like a second. Like a human being could never turn the wheel that fast. It was like it just whipped around. I was like, oh, whoa, don't get hit by the steering wheel, right? And then it did that, locked it, went back, and then at the last second, same thing. It just whipped it back around 3.5 turns the other way. And I was like, man, a human being would never park a car like that. You don't have the strength. You don't have the accuracy. You can't calculate that fast enough. You'd run into the curb or hit the car that you're backing around. So that was like, man, take your hands off the wheel, human, because you don't have the capability to do high resolution, high data density decision-making control. You don't have that ability. This is a machine. So that was really what got me started on this, because we were doing all this. I call it, Kenny doesn't mind, I call it the Kenny code. He'd probably laugh. It was like nanny code on the like a governor. You got a Corvette, and this baby, you got a 455 or 450 cc engine, back in, this is before electric cars, right? But you got a high performance V8, and this baby's putting out 450 horsepower. And then you put it to California, and they put all the emissions and governors on it and retard the performance and attenuate it. And you got this little equivalent of a V4, driving down the street, driving down the 405, this beast is ready to be unleashed. That's what we do when we try to impose human constraints on the machine.
Yeah, I think that's actually a really good scenario where where a vehicle can parallel park, and then the time it takes to react while parking continuously, adjusting for its surroundings. Yeah, humans can't react that quickly.
I think that's not going to break.
Really
the steering wheel's not going to break because it turned like 10 times as fast as I could turn it. It's not going to break.
Right.
It's just the limits, but yeah. I mean, my dad had one of those. Remember those little wheels? My dad was old school. He had one of those little wheels on it. He used to like ram.
Yep. Yes. Oh, yes. That's right. Oh man, I forgot about that. Yes. Oh yeah. Yeah. Watching that. Yes.
Yeah.
Yeah.
My dad could wheel a car like that. So after my dad, but yeah, that's old school stuff. But yeah, man, he get that little wheel and he's just woo. Like, ooh, whoa, Dad, you're like really very aggressive on that turning, the steering wheel. But yeah, that's, you're not impeding the AI or the machine to do what it's capable of doing. So yes, just get out of the way and let the high resolution machine do its job.
So obviously we know that AI is it's one of the biggest buzzwords that we have. Yeah. And there's a flood of AI in every sector. It doesn't matter where it is, whether it's building automation, home automation, cars. It doesn't matter.
Washing machines.
Yes. Yeah. Washing machines, even making images now.
Coffee makers, AI, and it's kind of ridiculous, but it's here.
So when you talk to managers and building owners, what is the most single point of friction they have about bringing AI into their plant?
It definitely is. Number one is IT. So the IT is still a big, it's a stumbling block. So I think that's one of the areas that we excel in, being able to have the IT conversation. Not trying to reinvent the wheel, understanding what an API proxy server like Apigee is, not Apogee, the Landis and Gear, but Apigee is an API GEE.
Yep.
That's a web, it's a web proxy server like Gateway. This technology exists. So the first thing the IT person says is no. And then, I'll bring up, first of all, the answer can't automatically just be no. Like, let's talk about this for a minute, because this is important. You're going to save $250,000 a year or millions of dollars a year, dude. So your company is going to be more healthy. Your employer is going to be more healthier to employees. So it can't just be no. Like, let's have a talk about this. And then you soon find that, what they really are looking for is the solution that's safest for them. And it's a collaborative situation. So going in with we've stopped going into IT discussions with FAQs and architectural diagrams, because they're inevitable. They're going to be wrong. So we're like, you tell us. We're not trying to give you a foreign box to put in your infrastructure. Spin your own VM up. It's your machine. It's secure, isn't it? Because you're the one that procured it for us on our behalf. So we're more like a solution consultant at that point. So I see the number one friction is IT. And then the second one, or probably equal, is that they know they have to have some sort of governance, just because that's a checkbox that their shareholders are talking about. So we've started to go through these governance and safety things on, safe AI and governance. And it really is just, checking the boxes that, is your AI safe? Well, yeah, it is. I mean, so we just kind of go through it and check all these boxes, and then everybody says, okay, we're good. We'll go ahead and put it on the network. And so those are the top two areas: is IT and AI governance and safety.
Yeah, one thing is data integrity is it's a massive piece of this governance puzzle. So how do you convince those stakeholders that are skeptical that the data being read and the control loops that are being adjusted are completely secure and won't disrupt building operations?
Yeah, that's a great question. So, first of all, we do a health check before the AI assesses makes any command output. So, for example, one of our customers, large retailer, discount retailer, they've got 2,000 stores, 8,000 RTUs. At any one time, our AI is only controlling 70 to 80% of the portfolio. So like 400 stores are not capable of being controlled by AI. They're low on refrigerant, their belts broken, they're oversized, undersized, not responding. I don't know, yada yada yada. It's just so our AI before it makes an output adjustment, it does an assessment, a health assessment on the unit, and it's like a report card. And if it doesn't get an A plus perfect score, it doesn't do anything. It just skips and moves to the next one, and it does that round robin. So yeah, we're saving enough energy based on the 75 to 80% of the portfolio to justify the cost and the ROI and value to the customer. So we don't have to be perfect. The data doesn't have to be perfect.
Yeah, I like that. I like that thought a lot. We talked about, taking the guardrails off, and you were able to convince Kenny to do that. So the question is, how do you negotiate that balance between tight governance and real world performance? Especially when you want to talk about taking those guardrails off and letting them go down.
Yeah, again, it's a reputation based business. This is trust. So first of all, you have to trust the people who are building the AI and the solution. I always call it like there's a three-legged stool of success that I think we excel in. Number one, you have to be a controls expert. So you have to know your way around central plants and mission critical equipment in mission critical venues like data centers, hospitals, laboratories, museums. Like we're in all those places. So you have to. So a part of this takes time. We didn't have this a year or two ago because we didn't have enough touch points in mission critical facilities. But now we have a dozen instances in facilities like this, and so we've earned that. So we've checked that box. We know our AI can run your equipment safely and securely and properly because we know about controls. Two, you have to be a master systems integrator. This gets down to the data sufficiency for the AI. Okay, check that box. We've got software gateway connectivity to a couple dozen control systems. I pretty much say it's 85 to 90% plus of the industry. We cover all the major ones, BACnet, Modbus, all that stuff, LawnWorks, OPC. But then we also have proprietary drivers to controllers like Danfoss in the refrigeration space where there is no BACnet or LAN. So we've got proprietary, I call them print drivers. So I think we've licked the data sufficiency issue there. So we have enough data to drive the great results that we're achieving. And then the third one, it seems like it's obvious, but you really want to have a company doing this stuff that has competence in AI, in artificial intelligence. So we go back to, I'm sure you guys have heard the story before. I was doing AI 20 years ago. I created the first AI predictive policing technology that was actually featured on CSI Las Vegas. So this was real Minority Report type stuff. I was doing AI 20 years ago. So I didn't just start doing AI 3 years ago when ChatGPT came on the line. So I think with the competence and expertise that we have in those three areas, that helps us build at least at an initial go ahead that, okay, these guys might know what they're doing in these three main areas. And then we get to prove that with the engagement, which is a free pilot. We don't charge our customers for the engagement. Free pilot, we put it in 30 to 45 days. If it works, we go to contract and payment. If it doesn't, we part as friends. And I don't think anybody in the industry is doing that.
So I do have a segue question here, and then I've got a follow up to this one.
Okay.
You mentioned master systems integrator. What in your mind is a master systems integrator? What do you think an MSI consists of?
Well, definitely having the tools and the toolkit to build drivers for whatever solution you might come upon. So not a lot of times, but I'd say maybe 10 to 20% of the time, we don't have a driver for the particular system that we're coming up against. So we have the expertise to write that driver for that particular customer to give them a solution that they ordinarily wouldn't have been able to achieve without our expertise as an MSI. So we have a lot of experience with, building drivers. I did that for JCI back in the 90s. I worked for Milwaukee. Like I developed a lot of drivers for JCI and Honeywell in the mid 80s. So Enterprise Buildings Integrated, that was actually my product, the EBI at Honeywell. So I have a long history of having, expertise as an MSI. And we proved that.
Okay. Wow. I didn't realize that you were on the for EBI. I didn't know that. I knew the JCI stuff.
Yep, I bought that to the United States in 1989.
Okay. All right. Well, that's a nice fun fact to know.
Yeah.
As you know, I'm still partial to good old Barbara Coleman Network 8000.
Okay.
I still love that.
Yep. Network 8000.
Yeah,
Santa Claus, Robots, I think was the password or something like that.
Yep. And you can't beat a Microzone 800. I really want someone right now to say, yeah, this controller. Well, no, the Microzone 800 will beat the brakes off of any controller right now that is out in the market. And you can quote me on that one. I will. It will be fight. I'm sure that's fighting words for a lot of people right now, and they're probably going to be mad at me when I say it. Nah, Network 8000, Microzone, the Microzone 2. Yeah, no, Microzone, you can't beat that controller. That controller is like Timex. It could take a licking and keep on.
I literally have some Network 8000 and some DMS 350s in the field.
Oh yeah,
at the data center, one of our data center customers downtown. Like there
you go.
We're integrated into old Robert Shaw DMS 35s, 350s, 3500s, and the old Network 8000, CD at Network 8000. So I think that's the expertise. And the thing about it is, you can't just, the institutional knowledge to connect to all that stuff is gone. Like you would have had to been tying into a Network 8000 using a VT100 terminal and knowing that the username and the password to that is embedded as hard-coded as embedded easy. That knowledge has gone away. So there's a lot of institutional knowledge that's been passed down, and you're unable to clean room reverse engineer that stuff because you don't know the password, the hard-coded backdoor password, Backfield, that was another one for those of you that know. But I mean, you don't know what the password is. You're not getting in. Doesn't matter how many billions of dollars you have. You're SOL. So
I remember when someone's like, yeah, can you integrate to that chiller? And I just had a GCM. Microzone's like, yeah, I can integrate to that. They're like, well, that's BACnet. I'm like, I don't know. I'm like, well, I don't know if it can talk BACnet, but I have a relay. A relay could talk to the chiller just fine and turn it on and off. Like I could integrate anything you want with electrical components. So let's do this. So when you're talking about scaling technology across a massive portfolio, you talked about the retail. The retail area that, you have, I think you said like 2,000 plus, 2,000 plus locations, and so like when you're building that, obviously legacy buildings are a tougher nut to crack. So where are you finding the smoother paths to scale right now? And what kind of infrastructure makes it a portfolio ready for deployment?
Yeah, another great question. You know what it comes down to? Stop trying to build our own custom solutions, controls people. Like follow what the internet has done. I remember the first time one of my buddies actually founded Net Zero. His name is KC Robinson. And I was like, KC, this is like 1996, 97. And I was like, KC, how did you guys tie 300,000 users together over phone modems? You got mail. I mean, these are modems, old school modems with the tones, 300,000 people at their height of net zero. And I'm like, how did you tie all those folks together? And this was 1996, probably 1997. And he said, oh, XML. And I'm like, XM what? Like, what's that? And he's like, XML, it's exchange format language, whatever, extensible markup language. And I go, oh, well, let me see that. And I'm telling you, when I saw that XML, I was like, this is the future of the building controls world. We don't have to reinvent the wheel here. IT, Avis, all the airlines, Expedia. I guarantee you that when you book a hotel and you book a flight and a rental car, that those three, Hertz didn't get together with American Airlines, who didn't get together with Hilton to pass that reservation. You came out with their web services, XML profile or whatever it was, as ancient as that is, and they didn't have to collaborate. They just had a WSDL file and they just gave it to them and it worked. And this is how the real world works. So we got to stop reinventing the wheel with this IT stuff. We have to run on what's there. So I push the industry. I take great pride in saying that I was one of the first companies. My company was one of the first companies to push XML. I was at the inaugural OPIX meeting. Like I did this XML symposium in 2003. And I showed one of my customers was USC, and I had XML running across a Network 8000, a Robert Shaw, a Train, a Honeywell system, all kind of stuff, Cutler Hammer, and it was all in XML infrastructure. And I put the article out on automatedbuildings.com and astonished the industry with this new technology to tie all these buildings together using this acronym XML. And so after that, a year later, a few of us met in a hotel in Cincinnati, and OPIX was born. That's how OPIX was started, based off the XML symposium. And I was one of the founders of OPIX, Open Building Information Exchange, which is XML based. And this happened 20 years ago. And we're still talking about new architectures, new, technology, while the rest of the world has moved on and they're using good old XML or JSON or whatever, web services, RESTful web services. They're not arguing about format or function or what the spelling of the point name is and all this other stuff. They're not trying to standardize this stuff. They're just using what works. I got a little plug. I got a great post coming out on LinkedIn tomorrow talking about that, because so that's how we scale. And oh, by the way, I actually have the United States patent on web-based enterprise energy management systems. I got that in 2001. So I'm also an enterprise scaling expert. Like, I'll go down in history. Tritium didn't invent that. We beat Tritium by 2 months. My first company, Silicon Energy, we got the patent on web-based building control systems. So been doing that for a long time.
Wow. Okay. That was a lot. Yeah. OPIX, I'm definitely familiar with OPIX. For those, XML, especially from a Niagara perspective, PX stands for presentation XML. So it is a graphical based, it is a graphic, but it is XML based. And the config.bog, fun fact, is also an XML type file. So there's a lot of XML that you see, in the back, especially if you're developing Niagara modules and objects, you'll find, like, when you're making a palette, it's XML. So a lot of that. So a lot of that's not new. It's been around for ages.
XSLT transformation, right? I mean, you blend the data and the graphical elements together in two XML files, and it creates the graph. It creates the HTML, the presentation layer to present that.
Yep, that's right. Absolutely.
That's how the whole world works.
You're right. So when you're looking at the market today, where are you seeing, what is the biggest untapped opportunity that you see?
That's a good one. I think AI. I mean, I might be a little bit partial, but I don't think we've begun to exploit the capabilities of AI in the built environment. I mean, it's just the AI is progressing so quickly, and pretty soon I think we're going to have, and your analyst on your building is going to be an agent that's just going to sit there. I'll give you an example. We have a hospital customer, and they were getting this simple OR report from their incumbent vendor, just temperature and humidity for each one of the 10 ORs. And they use that. They get this report spit out of the BAS at 5 o'clock in the morning. And then the facilities folks look at the temperatures and they say, okay, which one is most viable? Which OR is most viable? That's how they actually do it. So they look at I got 10 ORs to choose from. I got 4 scheduled operations. Which are the best 4 ORs to have these? That's how they schedule it. So this is like an OR readiness report, if you will. Hospital-acquired infections it's a huge thing with in hospitals. Like, a lot of people, they die from these things. So you really want perfect control and humidity control and temperature in an OR, because literally it's a matter of life and death. But we still have the human involved in it, looking at this stuff and making a judgment call. And so we were engaged to just provide to unlock the data from the proprietary control system or whatever, right? And I was like, but we could do so much more. No, that's all we want. Just send us the report in the morning. Well, I'm like, man, I can start trending this stuff. And I haven't sprung this on my customer, by the way, but they don't know it. But instead of getting just a simple OR report with static values at 5 o'clock in the morning static, they're going to get a whole narrative report generated by an AI agent. That's actually going to use historical graphs and everything. It's going to be a narrative. You should be using OR3, and here's why. Looking at the history and the historical performance, this is your best. The AI is going to make that assessment. We don't need human beings to be looking at this stuff anymore. The AI is does a fantastic job. So I just think AI is the great untapped potential for the future.
Yeah, I for hospitals, I have one here in South Carolina that I do a numeric latch, and twice a day I record the value and they get a report. Yeah. And it's exactly right. It's exactly the reason why you stated they want to look at the optimal room. But yeah, I think if you're looking at more historical data and see which ones are the better performing ones, you can reduce the risk of infection.
Yes.
By a lot. So I think that's actually a really interesting concept. I definitely would like to see that report for sure. That's a good one there. And I think that you're right about AI being an untapped resource. Like, people are trying to get to MCPs. Some people are trying to create a few in Niagara 4 and Niagara 5. It's going to be something that's just there, that people that can use. So, so there are some areas that are embracing AI, for sure. Go ahead.
It's just AI is just the ultimate prediction engine. Like, that's what AI is prediction. So another example that we're coming out next month with is one of our customer with the 2,000 plus stores, 8,000 units. Every year they get behind in Texas, Florida, California, and Nevada with the humidity. And for whatever reason, you got the design day, that unit is just not going to be able to make it on the normal schedule. So you start talking about rudimentary, optimal start. Well, let's start the unit up, an hour early. Well, let's try it at 2 hours early. Like, it's hit and miss. How about turning this over to AI and getting a weather forecast from a NOAA weather station and having the AI make a prediction of what the set point should be and when it should start up the unit. Not these fixed rule-based static systems. So yeah, it was something, because we actually made and this goes to what the common theme of what we're going on even on Monday Live. We talked about it today about how to turn your customers into what is called raving fans. So Kenny told me, he said, Keith, you got to read this book, Raving Fans. And I was like, okay. He said, that's what you're doing, but you don't even know you're doing it. And Raving Fans is about turning your customers into just that. Raving fans, like, you're going beyond the call of duty. So one of the things we did for 4 years now, we've always had trouble in the summertime in July with those 4 states with humidity control. And so I was like, in January, I contacted my customer. They're not paying any extra for this. I'm not making any more money. It's not about that. I'm trying to help my customer be more successful and keep their stores open longer during these hot humidity days. And I said, guys, I want to get ahead of this year. Like I want to bring the power. I'm not trying to charge you anymore. Same subscription fee. I just want to do a better job, and we have the tools to do that. So what I want to do is bring in a weather forecast using a NOAA weather forecast and predict how you should run the building, and not just generate a report, but let the AI make the decision and control the system, closed loop, right? And so it was something because they had been having, actually, this is a common thing because I was in retail before with my last company. Did you know like at any one time, 5 to 10% of the retailers have to actually shut their stores down when they have problems with their HVAC, like it can't keep up? They're losing revenue. And so the CFO actually called the VP of Finance or VP of Facilities and said, hey, we got to get ahead of this. Like let's just run the AC all night long. And I mean, and our contact, the energy manager and the VP of Facilities was like, you know what? We're working on that already with Facil. It was coming out, mid-July. And so we made the facilities folks look like heroes because we proactively went ahead and got aggressive on solving a problem that was impacting their revenue in a negative fashion.
Wow. Yeah, that's really interesting to think about. I've never thought about retail stores shutting down because of heat and they can't maintain the conditions.
Oh yeah. Huh. Happens more often than you would think.
So here's an interesting question. Obviously, I'm sure that you heard, Anthropic came out with Fable 5 for Claude.
Yeah.
And then the U.S. said, hey, I believe the U.S. said that they didn't want anyone outside of the U.S. having access to it, something to that effect.
Yeah.
And then Anthropic just said, nope, we're just going to pull it away from everyone. Pull it away. If everyone can't have it, then no one has it.
Yeah.
Kind of thing. What do you think was the trigger that you thought that the U.S. kind of had that knee-jerk reaction? Because I kind of felt that it wasn't really founded to pull it.
Yeah, I think it's fear of the unknown of what it could do. I don't think they had any thing concrete to back up that there was any danger. But yes, fear of the unknown of what this thing could do. And so I think they want to just rather be safe than sorry. Especially with it, and again, I agree with you. I don't think it's so much that they only wanted the U.S. to have it. I think they just didn't want anybody else to be able to get access to it that might use that against us. So this AI, that's the thing about AI. I mean, I think there is a slight danger in it, like figuring out stuff that we aren't able to figure out. But one example, I don't know if you ever heard of the what happened with the AI with the Wi-Fi router and the video with the wireframe stuff.
No, go ahead and explain that.
Oh yeah. So I don't know if you saw that. Remember that Batman movie? It was like he used the cell phones like a sonar thing, and he was seeing all the wireframe people in the building and all that stuff. So here's what they did, and this is the fascinating thing. Like a human could never do this. It's just impossible. So what they did was they hooked a ordinary old Wi-Fi router up to the AI, and then they hooked a video camera on the same room to the AI, and they asked the AI. They said, compare these signals, compare the signal strength of the router, and I guess as the people are walking through the room, they're breaking the wave. I mean, really, it's sonar. I mean, it's just light that we can't see. Basically, a radio wave. That's what it is. It's just on a wavelength that we can't see. And then they said, and the AI saw the people walking in the room with the video, and it saw the Wi-Fi signals. And then they took the video camera away, and the AI was able to reconstruct full motion video from the Wi-Fi signal.
Wow. So it captured every single movement and was able to determine how many people walked through and
Not only that, it wasn't just counting blobs. It was wireframes. It was
know what else it can do? It can also read vitals, heart rate, and your breathing and stuff like that. So it can guess who that person might be. If you think this room, it's a very, very powerful spy tool.
Threat assessment. Yep.
So if you had like 5 people in a room, you could assume that a certain person by their vitals is that wireframe, which is insane, but it's super cool.
Yeah. So to me, it's ridiculous to say that a human could ever take a Wi-Fi signal like with an oscilloscope and figure out and recreate a 3D motion video from it. Like, that's absurd, right? Why do we think why do we think it's just not as much absurd to think that we could control a mission critical central plant with all these moving parts as good as a machine? But for some reason,
that's actually a really good point. Yeah, it's a really good point. I mean, I guess in some ways it's what we know, right? So then, obviously the fear of fear itself, right? Like that's the big one. The unknown is I think the unknown is kind of the driving fear. Like sometimes even when you're watching, like I've seen it on like TikToks and whatever, where like you'll have like, in China where someone, they had a robot that was out there and all of a sudden like, it was in mid kick and a kid, got struck. Like, okay, look, that like, okay, like things like that are just going to happen. Accidents are going to happen like that. It's not, it's not that anything was done maliciously or anything like that. Like you got in the way. Like what do you kind of expect? So it's like watching that stuff is kind of interesting.
You bring up a great point. It's no different than getting in the way of a car painting robot when it's autonomously painting a car. Like you get in the middle of that thing and you get your head knocked off or whatever, because it's a machine. And so it's kind of interesting because our AI is actually based on it's a principle called iterative learning control within the frequency domain. It basically is a car painting robot. It's a set point adjusting robot, but I liken it to a car. Imagine a robot, typical car painting robot. They program it to paint one type of car, one geometry, one shape, so it knows how big the car, where the surfaces are, and how to keep away from it. Imagine if you created a car painting robot that could look at the car and assess how to follow the contours of the car, and it could paint any car. That's what we've done. It's the same thing. It's a robotic operator that can paint different cars. Control different pieces of equipment at different times during the day. It's still a multifaceted robotic process when it comes down to it. That set point of 75.7 degrees with the condenser water is like a broken clock. It's going to be right twice a day. So it's a matter of figuring out and dividing up the 24-hour period into 5-minute intervals and figuring out what the perfect set point is going to be at that temperature at that time of the day. And that's how our AI works.
Twice a day, I kind of feel like that's once more than some people I know.
Exactly.
I did tell someone one time, I'm like, yeah, broken clock is right twice a day, which is once more than you. I did. I was not happy with them.
Yeah, well, that's how we run our buildings. What's the set point? It's 78 degrees. Maybe outside air wet bulb +5, but most of the time it's the water. There's only 4 set points in a central plant. As hot as possible, so like 80 degrees or 70. As cold as possible because you want to increase the lift on the chiller. You want to help the chiller out, so that's 65. Outside air wet bulb +5, or not at all. You just kind of let it randomly drift, and that's it. But none of those is precise.
That's right. I mean, I think that's true. I think that, with design engineers that have a design in mind, it's like the smart air valves now that have come out for like VAVs, where that it's of the mindset of the mass. It's of the mindset that VAV boxes have been oversized for, well, pretty much their entire lifetime.
Yeah.
And now these smart air valves are coming out to have like a turn down of like 400% or more at times. So I think that's right. Like where we've designed things as humans because this is what we can calculate. But, obviously there are things that we can't necessarily see because we either have blinders on or it's just not in our frame to do.
Well, we changed the equations, based on, lighting projects is a great example. When that building was built in the 80s, it's been delamped. So you had a certain watts per square foot. Now, though, you replace all those incandescents and others with LEDs and you've removed 80% of the energy. So now effectively the VAV and the cooling system for the entire store is oversized because you delamped it and you removed the heating load from there. So now you're oversized. What are you going to do? You're going to go in and put a smaller unit in? No, the only thing you can do is change the operation of it accordingly.
Yeah, that's a really good point. I've had a lot of questions from controls companies. I'm in a few forums, and I'm a moderator and an admin of one of them, and that's DDC Talk. And a couple of them have actually talked about partnering up with companies like you, and obviously they weren't really aware of Facile.ai, and so like I said, hey, you may want to look into Facile.ai and potentially reach out. So for those people that might be interested, that they want to align with this wave rather than get left behind, what's that ideal partnership look like to scale the technology together?
Yeah, I think the first thing is that, and we're actively engaged with, a couple, not a lot, but major controls companies, and we're talking to them. They're talking to us. But it really is a better together story. That's what we're trying to promote. It's not the control system has the ultimate, control, pardon the pun, but it's the local loop control. We're just an add-on that's going to make the already great control system run a lot better in some cases, a little better most of the time, but a lot better in some occasions. So it's a better together. We're not competing with you because you've got a PID loop, the 100-year-old PID loop. As far as I know, there's no quantum computing yet or AI or machine learning inside any controllers now. I guess that might change in the future, but we'll see. But yeah, we're a great overlay. We enhance the experience of your customers. We're also used to scaling with the product, and we're actually in talks with a medium-sized control company about actually embedding our AI into their advanced controller, which is very exciting. Actually getting Facile inside, powered by Facile. So that's very exciting. So we're just trying to promote, and then by the way, you can also avail yourself of our connectivity options, to not only your product but your competitors. So if you want to if you're in a competitive situation, you could avail yourself of our 20 driver library to enhance your customers' connectivity experience and enablement. So that's where I see it. Like that's how we win together.
Another straight AI question. So, obviously there are products out there like HVAC controllers that have AI built into them, like the chip. And what seems to be happening is some of those products just don't have the capability of accessing the AI side. Just yet. They've got they've got the chip in there for it. It's just trying to figure out how to access it. So do you think maybe for them, like they need to use something like TensorFlow or TensorFlow Lite to kind of, that medium gateway to kind of send information back and forth, to and from?
Yeah, but I wouldn't necessarily say that TensorFlow would be the right choice. So, there's I get into like the different types of AI. So TensorFlow is, it's not a large language model, but it's not generative AI, but it's predictive AI. So, those outcomes when you're utilizing that type of AI is only going to be as good as the model that you build and train it on. And, that's why we've kind of moved to the third segment type of AI, which is called physical AI. So it's more along of inference, not training compute intensive, but inference. So think of a autonomous drone flying through a forest. Like that thing doesn't have time to retrain because there's a tree in front of it. And yeah, you got a second and a half to make a decision or you're going to crash into a tree. So you can't retrain. You got to make a decision left or right. You can't go straight. So the problem with a lot of and even the MPC, the model predictive control based systems, which have been around since the 70s, is that, again, it's only as good as the model. And the model is based on a human based model or digital twin. So we kind of see that as a limitation. We tried TensorFlow. I tried Microsoft Bonsai. We tried all the commercially off the shelf stuff for the first 3 to 4 years of our existence. We're 6 years old now. And we found that we had to do, it was more of a repetitive inference control. So we built our own AI for control. It's based on, ILCFD. We're actually getting a patent on it. It's patent pending. But yeah, when you move into the realm of control, you really have to let the AI build its own model because it's a human intelligence model, human model cannot power a machine intelligence capability. Like that's the difference between the Wi-Fi router scenario and a human. Like, so our AI believe is unique in the industry in that there is no human involved whatsoever. So it discovers the points on its own, analyzes those points, figures out which ones have a correlation of signal strength, if you will, signal to noise ratio. So when I move this point, the power goes down. And when I move it this way, the power goes up. So it figures out, it's a correlation engine. So it figures out on its own all those weak and strong relationships. And then it builds its own model and starts controlling. And it teaches itself. So I think that's the revolution with AI and machine learning over traditional commercially off the shelf, TensorFlow and the more standard. I don't think those AI technologies are suitable to task on a complex control system.
That's a good one. Thank you for breaking that down, by the way, because a lot of people aren't really familiar with that kind of stuff. And yeah, you're right. TensorFlow is good for predictive, and I think that's where I think a lot of I know in some cases predictive analysis is good for what they're trying to do, but obviously you're in a different you're in a different form of control. Like you actually want to control the building based upon the conditions that you're seeing.
If it was linear and two axes, like a cart pole, balancing the pole in the middle, you can see all that stuff. What if it was moving up and down and the pole was changing weight? Mm-hmm. That's what I mean. So, I always look at it like, how do you model a tornado? You can't. You know how you learn about tornadoes? You drive up close to them, you throw thousands of sensors into them, and you drive away like hell to get away from the. That's how you learn about tornadoes. So, a lot of people in our industry is like, oh, don't be like Facil. They're reckless. They're going to just control your chiller. They might blow it up. Hey, no, we don't do that. We do this beautiful 3D model of the chiller, and it's fancy. It looks impressive. And they're like, well, how did you generate that? Oh, we took all your nameplate data, and we've been doing this for years. And look at this digital twin. Ooh, it's pretty. It's like eye candy. And then that gives the customer a sense of false confidence in the technology because they feign expertise by using eye candy and stuff like that. No, our AI learns on the real machine. I can tell you at Kenny Central Plant or any other central plant that I've worked on in the last 40 years, you could have 3 identical, in quotes, chillers, And chiller number 1 runs differently than chiller number 2, which runs differently than 1 or 3. And we don't know what it is. It's the same chiller. It could be sunspots. I mean, I'm being facetious, but we don't know what it is. All I know is that each one of those pieces of identical equipment has unique characteristics. And so you have to have a separate model. They're like snowflakes, and the AI has to build that model and observe those nuances and those fine differences between those pieces of equipment, whether it's 3 chillers in a central plant or 8,000 RTUs in a retail customer's portfolio. You could have the same type of RTU, all 8,000 of them. You could standardize on them, but they're not going to be the same.
Hey, here's a hot water heater that a domestic hot water heater you can control. Well, you know, I mean,
that's hilarious.
It is what it is. Like, we do that. But have you seen this hot water heater we have over here? Man, that looks really good. I have that in my house. Exactly. So I have one last question I have for AI, but then I have a really important question as a follow-up. Okay. So the one I have here is, I guess is a two-parter here. And then I have I think the most important question of the evening. So like, let's say we're looking down the road the next few years. So what is going to be your boldest prediction, Mr. Keith Gipson, for how AI is going to transform daily life and the average, facility technician? Like, what does the building of the future look like when the algorithms are doing the heavy lifting in your eyes?
I think it's the end of the stationary operating engineer. Serious, like is there going to be robotic operators? There's going to be cobwebs on that seat where the front end is. I mean, humans are going to be freed from doing this mundane monitoring and adjusting and babysitting. I think that it's going to revolutionize and allow us to do even greater things and focus on more important value add issues. I mean, I think the days of staring at a dashboard are going to come to an end, and it's going to be very quick too. It's going to be quicker than people realize.
All right. Now, this was all great. I think it's always great having you on here, but I had to save the best question for last. I just did. It was one where I was going to bring in a little bit earlier. I was like, no, we're gonna end on this one. So, a lot of people don't know that you are a karaoke super fan. Yes. And so what was your favorite duet that you did?
I'd have to say there's a song, it's called by Tracy Atkins. It's called "You're Gonna Miss This." It's a country song. So my wife and I, we love doing that song together. So she's in the background, you're gonna miss this, and she's in the background doing it. That's a favorite one of ours. And then also we also do a lot of kind of like Jackson. Like I love the Jackson 5, and so so in that case I don't really do a duet, but I'm like Michael Jackson with the high pitch, and then I'm also Tito and Jermaine with the low. So I get a kick out of doing that. But
there you go. You're the whole group. That's what you are.
Yeah. I mean, they just get a kick out of it, man. It's so fun to do that stuff. Coming out with the, the high and the low. So.
Well, good. No, Matthew was like, hey, you got to ask him about that. I was like, all right, I will. So this is coming back. Mrs. Wilcox, she was my second grade teacher. And she loved the Jackson 5. Oh, man. And so in elementary school, we would always, and she did this every year. So everyone knew if you were in the second grade, you knew what song that you were going to sing for like the Christmas, the Christmas special that they all had.
You Kissing Santa Claus?
No, she give love on Christmas on Christmas Day or whatever. She loved that one. But yeah, the other one, Mommy. Yeah, I saw Mommy Kisses Santa Claus. That's also a good one. But yeah, she loved that one always. But yeah, she was a Jackson 5 fanatic.
Oh man, we just have such a blast. I mean, when my wife and I got married 5 years ago, we both lost our voice because we were doing too much. We were just overdosed on it, like newlyweds, was it, sex on? No karaoke. We just lost our voice and we're like, let's do it again.
That is great. Well, Keith, thank you so much for being on the show again.
You're welcome.
It's always good to talk to you. Good to see what you're doing. You're doing big things out there.
Yeah, thank you. We're having a lot of fun. We're having a lot of fun. We brought Thomas Wise in as our CRO, and we're starting to ramp up earn a lot more projects with happy customers. So I'm just really having a blast. Great times.
All right. Well, fantastic. Well, Keith, you have a fantastic evening.
Okay, you too. Thank you very much.
Thanks, Keith.
All right.
All right. Thank you. All right. Well, that's all we have for this episode. Remember to stay curious and go ahead. Let AI take the wheel. Until next time, I'm Charles.
And I'm Matthew.
And this has been It's a Controls Problem.
Let me fill your heart with joy and laughter.
There we go. Oh man.
Yeah,
all right.
Here to comfort you.
Oh man.
All right.
Jesus, take the wheel.